Got milk? That was an ad I heard all the time as a kid. Drink milk for strong bones, kids. And I'm not gonna lie, it kind of worked. I did drink a decent amount of milk. But why was it so important that kids have strong bones? Well, a very real problem is weak bones. Think of an elderly person that breaks their hip, or a military cadet with a stress fracture, or just someone playing basketball and getting a stress fracture. It's a very real issue. In horses, it's an even bigger deal. Think about it. Horses can't sit down a lot. They're standing most of the time. They can't rest in a wheelchair or use crutches, so a fracture is pretty bad. So fractures are bad, all right? But why is it important that kids need strong bones? Well, it turns out that the exercise that we do as kids strengthens our bones, and it actually lasts into adulthood. The more we exercise as kids, the stronger our bones. Now, adults, we can exercise, we can get our bones a little bit stronger, but it's not going to be to the same level as if we'd exercise as kids. Okay, kids should exercise. I argue so should horses. So I did that. I took 12 foals, baby horses, and I exercised them for 8 weeks at a moderate exercise study that I knew wasn't going to hurt them. And then now, okay, I want them to exercise. I'm hoping they're getting stronger bones. How do I measure these stronger bones? The gold standard is CT, computed tomography, or CAT scan as a lot of people call it, but that's frankly expensive and a little bit impractical. Is there another way to measure this? I thought there should be. So I took blood and muscle samples from these foals because I'd heard about these things called myokines, proteins produced by muscle that actually go and talk to bone. And I wondered, are they changing when these foals are exercising? And could they actually serve as a proxy for bone changing? And so I compared my data. I looked at my exercise foals and my non-exercise foals, and I saw that, eureka, there is a difference. I'm finding 8 myokines that actually seem to increase with exercise, either in the foal's blood or in expression levels in their muscle, and they actually decrease with growth. Now, this will hopefully serve as a foundation that one day we're going to have a blood test that humans and horses could possibly take to actually show if our bones are changing with exercise. And wouldn't that be kind of cool?